Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss chemical properties of alkene. Last class some properties was remaining. Today I will finish it. Okay. Chemical properties of alkene. In that I have discussed addition of sulfuric acid, addition of water, oxidation, and now I am going to discuss ozonolysis. Ozonolysis of alkene involves the addition of ozone molecule. Addition of ozone molecules O3 to alkene means ozone will react with alkene and it will form ozonide. O-Z-O-N-I-D-E, ozonide. Ozonolysis. What do you mean by the ozonolysis? Then it is the addition of ozone to alkene. That is called ozonolysis, and product name is ozonide. And after addition of ozone to alkene, it cleaves. There will be cleavage of the ozonide by ZnH2O. After this formation of ozonide, there will be cleavage of the ozonide by ZnH2O to smaller molecules. This reaction is highly useful in detecting the position of the double bond in alkene or other unsaturated compounds. This reaction is very, very useful to detect the double bond. And example I am telling you, propene. Propene you can take as example, CH2CH double bond CH2. Okay, this is the propene. One single bond, one double bond is there. Then this propene plus O2, it forms a propene ozonide. But here its structure you can understand better if you will think that this reaction is taking place in space. Then you will understand very quickly. Oxygen is that ozone is O3. Then 3 bonds are there. O3. Correct? Oxygen 2 bond, O2, but ozone O3. Then now this oxygen, this 3 oxygen atom will break. Oxygen atom will break, and all three oxygen will join with 2 carbons. Means carbon double bond was there in propene, carbon 1 and carbon 2. Between carbon 1 and 2 double bond means carbon 1 had a double bond. Both bond will break. Then both carbon will have 2 electron. Correct? Then now what will happen this 2 electron? Then there also in ozone that 2 bond will break. There also ozone that 2 bond will break. O3, just like a triangular, you can think that bond will break. Then what will happen? two oxygen will get one electron, and third one also will get 2 electron, because in ozone one ozone is attached with 2 oxygen. One oxygen is attached with 2 oxygen in ozone, O3. Then when this one oxygen which is attached with the 2 oxygen, that bond will break. It is attached with the 2 oxygen, then both bond will break. Then what will happen? That then there when one bond will break, then both oxygen will share one electron. Like that way, again other bond will break, then again both electron will share, one electron will be shared by both oxygen. Then now what will remain there? One oxygen will remain with 2 electron, and that 2 oxygen which are joined by a single bond, now only both 2 oxygen, remaining oxygen is divided into 2 parts. Then first part, 1 oxygen has 2 electron after breaking the bond, and other oxygen, OO bond is there. Then the bond which was broken, from that each oxygen has one electron. Means three oxygen each have one electron. Correct? This is the situation. 3 oxygen, and all oxygen have, first oxygen has 2 electron, other 2 oxygen has one electron. Then this is the situation of ozone. Now this will join to the 2 carbon. This will join to the 2 carbon of propene. Propene also both bond broken. Then 2 electron each carbon has. Each carbon has 2 electron. Then these 2 electron will make a 2 bond. One bond with one oxygen which had 2 electron. 1 electron of that oxygen and 1 electron of carbon. One bond is formed. Again with the same oxygen atom, other electron will form bond with other carbon, because that is also have 1 electron. 2 electron have but 1 electron of carbon, 1 electron of oxygen, which was having 2 electron. They will make a bond. Then now 2 electron of carbon is used up, 1 from each. Each carbon, one electron is now used up, and they have made bond with oxygen, which was having 2 electron, that oxygen now you can say both carbon is joined via oxygen, not directly. C is joined with O and O is joined with carbon. Correct? Now again you can see this 2 oxygen, OO is remaining, each is having in second part of ozone after breaking. Then both oxygen, OO is joined by single bond already. Then both oxygen now have one electron. Then these 2 electron, again it will join with the both carbon, because each carbon was having 2 electron. Then one used up with the first part of ozone, O. Now that second part of ozone, that is OO, where each was having one electron, oxygen, that will make bond with each carbon, because both carbon have one electron. Then another bond, carbon, now again one more bond will break. First carbon will make one bond, again that second carbon, that also will make one bond. Then in a space you can understand better, because the angle difference is there. Anyhow, you can make a diagram on the paper also. Then both carbon is making bond with one oxygen. Correct? Upside you can show, you can write or can make a diagram. Upside one oxygen and 2 bond is there. One bond is attached with the one carbon, other bond is attached with the other carbon. And other 2 carbon, OO, that will again it will make one bond with one bond with each carbon. Then this compound is called ozonide, propene ozonide. This is called propene ozonide. Now this is unstable. This compound is unstable, and in the presence of Zn plus H2O, in presence of Zn plus H2O, this compound will break and it will give two smaller compound. Two smaller molecule it will give. One will be ethanol. Ethanol means acetaldehyde. Acetaldehyde, CH3CHO. CHO is called aldehyde. CH3 is attached. Then acetaldehyde, also called ethanol, because two carbon is there. And other compound, it will form formaldehyde. Here also aldehyde is there, CHO, but H is attached. One H means formaldehyde, also called methanol, because one carbon is there, that's why methanol. If two carbon is there, then here other part, then ethanol. Then this ozonide has broken into two parts, smaller parts. One part is ethanol, other part is methanol. Then this is now stable. Then this is actually balanced, already is there. If you will see how converted, then this first carbon CH propane was there, then CH3 was attached with other carbon, then that is the CH3, and CH was there, CH and one O, upper oxygen, one oxygen was there, that oxygen came. Then it formed, because CH and O bond was there, a single bond, that what they form a new bond, both carbon, only that carbon will, that you can say carbon bond, C and one will break. One new bond, what was the formed? One bond was formed with both carbon. OO had formed two bond with two carbon. Then that you can say C and oxygen, one bond will break. Out of two bond they formed with OO. That one bond will break. One bond will break. Correct? Then when one bond will break, then what is remaining? Then one part will be clear. That CH3CHO, CH3CHO, but that oxygen also which was joined with other carbon. One oxygen was joining with two carbon. Then both, you can tell, both bond will break. That both bond will break. But OO, which was having one electron, two oxygen, that will, only one bond will break. And that first, only one oxygen which was having, making two connection with two carbon, that both, that one bond will break. One bond of that and one bond of down, means OO. Ozone had two parts, then both part, after joining with carbon, two carbons, then with one carbon up oxygen, OC bond will break, and one bond down, C and O, that bond will break. Then it will form two product. Then this is the CH3, one product will be CH3CHO, and CH3, and other product will be formaldehyde. But here you can see that there were three oxygen, but in product only two oxygen is there. What happened to the third one? CH3CHO, one oxygen, and formaldehyde, HCHO. Then two oxygen, okay, is there. Carbon is also not a problem. That total hydrogen was there. Total hydrogen 3 plus 1, 4 to 6. 6. Here also it is 6 in CH3CHO. C is 2. Total carbon is also balanced. Hydrogen is also balanced. Oxygen is not balanced. One oxygen is less. Then what happened? That one oxygen, then Zn is there. That Zn has taken one oxygen and it formed ZnO, zinc oxide. But main product is acetaldehyde and formaldehyde, means ethanol and methanol. Other, you can say, other example I am giving you, that is also very, very important. Both reactions are very, very example for examination. Very, very important, both. Now, second, I am telling you, now that time we have taken example of propene. One methyl group was attached, CH3, CH, double bond, CH2. That was the propene. Now CH3CH. Now that H will be replaced by another CH3. Then it will become CH3CH3, 2-methyl group. 2-methyl group will be attached with the carbon, and that carbon is attached with another carbon with double bond. That is the ene, double bond. Then now this time it formed 2-methyl propene. In the beginning it was only propene, CH3CH, double bond CH2. Now CH3CH, that H has gone and another CH3 came as a branch. That's why it is called 2-methyl propene. 2-methyl propene. Then now here also all things will be same. All things will be the reaction will be the same, because that time reaction was with double CC double bond. That was only involved. Here also only that will be involved. And this CH3 that has no meaning here. Only just it has made this molecules complicated, means complex molecules. You can tell big molecules it will form because 2 CH3 is there. And now double bond condition will be the same. What was I discussed earlier? Both are same. It will also form ozonide. Only difference is there. That time only one CH3 was attached, one H was there. Now that H is not there. In its place another CH3 is there. And upside one oxygen. One oxygen is joining 2 carbon. And both bond is broken. Here also both bond is broken. Then one oxygen of ozone is joined upside. One oxygen is joining 2 carbon upside, and down 2 oxygen is joining with both carbon. Same way, carbon double bond was there, that has gone, and it has formed new bond. One bond, one oxygen linked 2 carbon via oxygen. The 2 carbon is joined via oxygen, correct, upside, just like a inverted V. And down again same way, OO was there, and they both OO joined with carbon, because one electron both oxygen had. This is called ozonide. And here you have seen in the first case it was forming ethanol, acetaldehyde. Now here what will happen, because due to that H, one H was there in second carbon, that's why it was CHO. But now that H is replaced by CH3. That's why it will form acetone. It will form acetone, and that is also called propane 2-one. Propane 2-one, because that carbon number 2 now oxygen is attached with a double bond. H is replaced by CH3. That's why CH3 COO, acetone, common name. But IUPAC name is propane 2-one, because at carbon number 2 oxygen is attached with double bond. And other product is formaldehyde only. Okay. Then this is very, very important reaction. Here also one oxygen is not there, only 2 oxygen is there. Only 2 oxygen. One oxygen Zn has taken, because condition is same, Zn plus H2O. Okay. Then now I have told about the ozonolysis. This is the very, very important reaction, fit for all examination. Okay. Now next properties is polymerization. Polymerization. This is also a very important reaction. And you might be knowing about the polymerization. Okay, we have seen polythene bag, and it is every time now you are using polythene. That is the due to the polymerization of ethylene. Ethylene. When many, you can say, ethylene will join to each other, then it will form many. Many means poly, more than one, 2, 3, 4, 5, 6, maybe 100, 200, 300, depending upon the size of polythene. Then when many ethylene molecule will join to each other, then it will form polythene by the process of polymerization. MER means one unit, like ethylene. Then here polythene sheets you have seen, polythene sheet, polythene bags is common. Polythene is obtained by the combination of large number of ethene molecules at high temperature, high pressure, and in the presence of a catalyst. Three things are required: high temperature, high pressure, and suitable catalyst. Okay, maybe nickel, maybe copper, any palladium, PD, PT, any catalyst should be there. Okay, the large molecules thus obtained are called polymers. The reaction is known as polymerization. The simple compounds from which polymers are prepared is ethylene. Okay, and that unit, one unit is called monomer. Mono means one, and one unit MER, monomer. Then simple unit is called monomer. Example is ethylene. And other alkenes are also undergo polymerization, not only ethylene. If it is acetylene, then polyacetylene it will form. Okay, and that polyacetylene is very, very useful. Polyacetylene, that is a conducting polymer. Current can pass through this polyacetylene, just like it will in the form of a wire, and current can pass through it also. That is called conducting polymer. The best polyacetylene is the best example of conducting polymer. Then now here I am talking about now how polyethylene how will form. Then here small n means number of ethylene molecules. Then NCH2 double bond CH2 means many molecules of ethylene you will take. N, as for example, n molecules you have taken. N into CH, in bracket you write CH2 double bond CH2, and N outside means n number of ethylene is there. And at high temperature, high pressure, in presence of catalyst, it will give actually a double bond will become single bond, CH2, single bond against CH2, and bond broken, that both carbon just valency is open to joined. Just you can show by one dash both carbon, and that you write inside the bracket, means CH2 is joined by now single bond, and because that bond broken, second bond broken, pi bond, then both carbon have one electron, means a valence electron. One valence electron is there, that you can write as a dash opened for other molecules to attach. Okay, other also will come in this form only. Other ethylene will be also in the same form, CH2 single bond CH2, each carbon 1 electron. Hence, obviously, they can make bond both ethylene unit have 1 electron, valence electron, and they can join. Like that way, first can join with second, second can join with third, third can join with fourth, fourth can join with fifth. Like that way, as it will go. Okay, then it can make very long. That you can write it as a in a simple way. You can't write a very long chain. That simply you can write CH2 single bond CH2 both carbon just dash you write left side dash right side dash, and this you write in one small bracket, and outside you write N, because N number of ethylene joined to each other. Hence it will form polyethylene. It is called polythene also, polythene, ethylene. In shortcut you can tell polythene. Okay, this I have told you. Now another example I have told about the these things, polypropene. Then polypropene here, now propane will be repeated. Same way. Now that n molecules of propane you will take, n outside you write, and inside CH3 CH double bond CH2. Okay, and it will polymerize at high temperature, high pressure, in presence of catalyst, and it will give what it will give. Now CH3 is in propane, CH3 is there, that you can write as a branch. Then now same condition will be there. What was with ethylene, polyethylene, same condition. Only here methyl group, propane is there, then methyl group will be down as a branch. And again same thing will happen. Both carbon will have 1 valence electron. Double bond will become single bond. And again it can join with other molecules. Same way as a polyethylene. Then now how will you represent this? Then again same way you can represent CH. Now because CH2 was there, then one H replaced by CH3 in case of propane. In propane CH3 CH. Correct? Only one H is there. One H replaced by CH3. That's why it became propane. From ethylene it became propylene. Then now one more H is there. That only will be there. And this CH3 CH double bond CH2. Then this CH3 that will come under the branch. Then now situation is the same. Double bond will will convert in single bond. Each carbon will have 1 valence electron, and other propylene will also join to each other, second, third, fourth, and always CH3 will be down only as a branch. Then you can write you can represent it as a CH single bond CH2, because double bond converted to single bond. Then CH single bond CH2, and both carbon 1 valence electron is there, means 1 dash. That write in a small bracket, and outside you write a small n, because n propylene joined. Then this is called polypropylene. Polymers are now just used, you can see. Polymers are used for the manufacture of plastics, plastic bag, squeeze bottles, refrigerator dishes. In refrigerator you have seen it's required plastic dish. Refrigerator dishes, toys, pipes, already you have seen. Radio and TV cabinet, upper cover, radio and TV cabinet, etc. Polypropylene is used for the manufacture of milk crates. You have seen that milk nowadays they will put in one this things utensil like that, you can say, that is made from polypropylene. It is a hard, actually hard. tray like that. It will be just like a tray made up of you can say this polypropylene only. Polypropylene is used for the manufacture of milk crates. That is called milk crates. A tray like that you might have seen. That is a strong this where milk they will keep milk seller. Particularly this 1 liter, 2 liter, 1 liter, half liter milk they will keep only in that tray, big tray, and that is called actually crates. Plastic buckets, all buckets, a plastic bucket you have seen, and other molded articles. These plastics are very useful. You know, many materials are there made of plastic. Bucket is the best example. Tray is the plastic tray. Is the pipes, radio and TV cabinet. These are the examples. Okay, and these materials actually have now become very common. Excessive use of polythene and propylene is a matter of great concern for all of us nowadays, because now after we use they are throwing here and there, and then it creates a big problem. Polythene bags nowadays it is creating big problem. They will throw in drainage and this that, and it will be jam. Then it creates nowadays big problem. Even some animals, they will cows, buffaloes and other animals, they will swallow also inside. That creates problem for animals also. Now because people will throw all the can say garbage only in that bag, and this animals will eat along with that plastic. Okay, then nowadays we should use it, but with these things we should not be misused. Use it, don't misuse it, and throw it in a proper way. Okay, then this I have now this all chemical properties of alkene is finished now, and I am going to start alkynes, triple bond. Okay, triple bond, alkynes. What is actually alkynes? Then now it is very clear. Between carbon, if triple bond is there, then it is called alkynes. Whatever long chain may be there, at least one chain should have triple bond. Maybe 3 carbon chain, 4 carbon chain, all may be single, but at least one may be triple. Between 2 carbon, triple bond should be there. Like alkenes, alkynes are also unsaturated hydrocarbons. Okay, this is also a triple bond is there. Now obviously it will be unsaturated, and here you should know that triple bond is there. Then it can, if one bond will break, then it will become double bond. That is the ethylene. Again ethylene will that double bond will break, then it convert to the alkane, single bond. Means from the triple bond, double bond can form, and double bond can convert into a single bond. Then it will form alkane. Then alkyne can convert to alkene. Alkene can convert to alkane. Okay, this you keep in mind. And alkane is saturated because single bond is there, carbon everywhere. When single bond is there, then saturated, and if double bond is there, then it is called double or triple bond is unsaturated. Then this I told you, this alkynes contain at least one triple bond between 2 carbon atoms. The number of hydrogen atoms is still less than the number of hydrogen atoms is still less in alkynes. Only 2 hydrogen each carbon will have, because triple bond is there. Then 3 valence is carbon, 3 valence is full, then 1 valence is remaining, that is attached with the hydrogen, both side one hydrogen. Hence it is a formula C2H2, C2H2, okay. Then you can write HC, triple bond, again CH, HC, HC, again triple bond, CH, you can write like this, HC, and after that between two carbon, triple bond, and again CH. This is the actually this alkynes, YNES, alkynes, and it's like alkane, alkyne is also general formula. Then here, because two hydrogen is further less, then see how all three are related. CN, H2N plus 2, that was the alkane, and in alkene these two hydrogen gone, then now become CN H2N, that is the double bond alkene, and now two hydrogen further it is less. Then what will happen? From the 2N minus 2 we have to do. 2N is the number of hydrogen. What was the in alkene? Now from the alkene 2 hydrogen less. Then in formula it will be CN H2N minus 2. CN H2N minus 2, because 2 hydrogen is less than alkene. This is the general formula for alkyne. This question is also asked. The first stable member of alkyne series is ethine. Ethine stable, this is the stable, you know. Ethine, YNE always will be there. This is the first stable member of alkyne is ethine, which is popularly known as acetylene. Acetylene means one hydrogen is attached, only one hydrogen. HCH, HC, triple bond, again CH. Okay, only both carbon has one hydrogen. Then first member is ethine and popularly known as acetylene. Acetylene is used for arc welding purposes in the form of oxyacetylene flame. Very important use and application I am talking about. Question is asked. Acetylene is used for an arc welding purpose in the form of oxyacetylene flame. How we will get this flame? Obtained by mixing acetylene with oxygen gas. Acetylene plus oxygen gas. There you have seen ethylene plus ozone gas was there, but here it is oxygen plus ethylene. Okay, this acetylene plus oxygen, then it will form oxyacetylene. It will form, and when it will burn, it will give flame that is used in for welding purpose. Okay. Now alkynes is gas. All three are gas, you know. Alkynes are a starting material for large number of organic compounds. Hence, it is interesting to study this class of organic compounds. Like other you can say compounds like alkane, alkene, you have studied nomenclature, particular nomenclature for alkane, alkene. Now for alkyne also you have to should know particular IUPAC name of alkyne. Okay. Then just I will brief you some few, you can say, compounds and its name. Okay, because you should know. Then you know that first is the C2H2. First member is C2H2. Stable. Carbon is 2. Then C2H2. In formula you put the value of n. You will get C2H2. Then you will get C3. Then make it double and do minus 2. Then here what if it is a 3? Then C3H4, because make it double, 6 minus 2, 4. Then C3H4. Then if it is carbon is 4, then H will be 2 into 4 minus 2. means C6. Then it will be C4H6. And if it is 5, 3 I told you, no, 4, then 4 into 2, 8 minus 2, the C4, C6. All I told you. Then this is the actually formula. And here, that obviously if you write the structure, then in the first case C2H2, 2 carbon will be there, H is attached. If it is 3 carbon, then CH3, C, triple bond CH, CH3, it is attached with 1 carbon, and that carbon is attached with another carbon with triple bond and 1 H. CH3, C, triple bond CH. Like that way, C4H6 you can write, then 4 carbon there, and everywhere except one triple bond. Except one triple bond, everywhere you fill it with the hydrogen, simple way. And just to check it, how many hydrogen is there. Obviously, that number will come, what you want. That number obviously will come. Then like that way, for C4, 4 carbon will be there and 1 triple bond will be there. And everywhere tetravalency of carbon should be fulfilled. And then you have to fill it with hydrogen. If 5 carbon is there, the same way. Then like just like you were telling this thing, ethene, here it will be ethine, propine, butane, pentine, YNE will be there. And now it's a common name, the carbon number 2, common name will be acetylene. And when carbon is 3, that time it will be methyl acetylene. When carbon number 4, then it will be ethyl acetylene, ethyl 2 carbon. Okay, total is 4, ethyl acetylene, because in acetylene 2 carbons are there, ethyl is also 2 carbon, ethyl acetylene, if it is a 4 carbon. And if 5 carbon, then it will be dimethyl acetylene. Means every time acetylene you have to use. In the beginning, when 2 carbon, then acetylene, 3 carbon, methyl acetylene, 4 carbon, ethyl acetylene, 5 carbon, dimethyl acetylene. And what will be the IUPAC name? This is very, very important. This I told common name, acetylene, methyl acetylene, ethyl acetylene, dimethyl acetylene. This is a common name. But now IUPAC, acetylene is called as a ethine, YNE. Always YNE will be there, ethine. If 2 carbon, 3 carbon, propine. If 4 carbon, then butane, but you will correct by tell BUT, but dash 1 dash YNE. And again 5, then you can write but dash 2 YNE, wine. Okay. If 4 carbons are there, only then butane will there. If 5 are there, then pentine. Correct? Then this I have told about the distance nomenclature. And isomers, same way, isomers you can write. As for example, I am telling you 5 carbons means pentine. Pentine is there. Suppose pentine means first carbon have 3 bond. First, second, between first, second, triple bond. That is called first carbon, only triple bond, not the second. From the starting, that carbon is called. Carbon 1 has triple bond. Okay. Wherever it is there, just after the numbering, from where numbering is started, that carbon is given the can say number of triple bond, carbon having triple bond, that number. Then pentine, you will write same way, you write that 5 carbon and 1 carbon between one first and second carbon, triple bond, and all you fill it by hydrogen, simply. Then here, because first carbon triple bond is there, hence you will tell pent. Pentene you are not writing, only PENT. pent dash 1 dash YNE, because carbon number 1 triple bond is there. If double bond is at carbon number 2, triple bond is suppose carbon number 2, then same way pent 2 YNE means pent dash 2 dash YNE. Like that way, if it is attached with as a branch, now this pent is there, but now one carbon is attached as a branch as a methyl, then total will be 4. Total carbon will be 4, and now suppose carbon number 1 double bond is there, and carbon number 3, that methyl group is attached. Then now it will be 3 methyl, 3 dash methyl, 3 dash methyl. Finally, it is a butane, then but, and carbon number 1 actually triple bond is there. That's why you will write 3 dash methyl but but dash 1 dash YNE, butane. Okay. Then this I have told you, there isomers. Here 3 structure I told you. Then first and second structures are position isomers, because bond only triple bond position is changing. One time it was at carbon 1, now second time it is a carbon 2. Okay, then it is called position isomers. And the structure first and third. First structure is a straight line, third structure is a branch. Then this is called chain isomer. And same way, structure second is also a straight and third is already no branch. Then second and third also is called chain isomers. Okay. Then here I have told you isomers. Here you should know that if suppose 5 carbons are there, then you can start numbering either from one end, first end, or the last end. You can keep triple bond either from the left side or from the right side. But just because both end, carbon 1 and carbon 2, carbon 3, these are differing only from the first, second, third. If you count from the right side, this is from the left side, first, second, third is different. Like that way, from the second side you will count, then this fifth, 4, 3, this will differ, and first two will be common. If you are starting from the left side, then first 3 carbon is different, and if you are counting from the right side, then only from the last 3 is the different. That's why only 3 up to 3 you have stopped, 4 you have not written. 4 methyl, 5 methyl you have not written, because that is the same thing with what first and second was there. 5th and 4th is the same things. Okay, this always you keep in mind. That's why if 6, 7s are there, you can't write at carbon number 5 and carbon number 6 like that. Any one place, it should not be equal. Okay, first beginning 3 is different. Last, if you are counting from the last, that 3 is different. But if it is a odd number, then you can write. But you see that it should not be common, like first, second, third. From the right hand side, again first, second, third should not be there. Right? Different new should be there, different should be there. Then this I have told you about the distance isomerism of ACT, isomerism of alkyne, isomerism of alkyne. Now I am going to tell about the structure of triple bond. The structure of triple bond. Then now already I have discussed alkane and alkene, how they are making double bond. Here what is the main things to understand, that now here sp hybridization will be there. In case of alkane, sp3 hybridization was there. Each carbon was having 4 sp3 hybridized orbital, 4 number. Okay. Then one sp3 of one carbon and one sp3 of other carbon had joined in case of alkane and formed a single bond, sigma bond, single bond, sigma bond, and rest CH3, rest sp3 hybrid orbital had joined with hydrogen, s hydrogen, s orbital of hydrogen, and s and sp3, s orbital of hydrogen, sp3 orbital of carbon, they made single bond, that is also called sigma bond. Okay. Then in alkane, 3 left side, 3 right side carbon formed. Total 6 plus 1, 7 sigma bond was there, one between the carbon. Okay, between the two carbons, sigma bond, sp3, sp3, and with hydrogen, sp3 and s. H has s orbital, then sp3 orbital and s orbital. Then like that way, 6 was there, 6, 3 left side, 3 right side, then that is also sigma bond. And carbon what they made, that is also sigma bond. That was the total 7. That is in the case of alkane. Alkene, sp2 hybridization was there. sp2, 1 s and 2 p orbital out of 3 they have taken part. One was not taking part. Then that time they formed sp2. Only 3 was there, 3 orbitals. Then 1 orbital of one carbon, other orbital, sp2 orbital, other carbon, they made bond, sigma bond. And 2 sp2 as remaining, they made with hydrogen. Same, s and sp2, s and sp2. Other carbon also same way. And 1 orbital was remaining, p orbital was remaining, which has not taken part in hybridization, but was having 1 electron. It was 50% up and 50% down, its orbital will be there, dumbbell, like that way. Electron will be moving upside, downside. Then 1 or p orbital was remaining. In second sp2 I am talking, 1 orbital was remaining on both carbon, and both carbon were overlapping, and they bond pi bond. That is also called sidewise overlapping. Sidewise overlapping. Okay. Or lateral overlapping. Lateral, 2 terms are used, sidewise overlapping or lateral overlapping. This overlapping is less, that's why pi orbital is weak. Now in this case, sp hybridization is there. It means 2p orbital has not taken part in hybridization. Then only sp hybridization is there, means 2 orbital is there, sp orbital, 2 sp orbitals. Then 1 sp orbital of one carbon, other sp orbital of other carbon. Both joined axis wise, they formed single bond, sigma bond. And 1 orbital is remaining, sp, that made with s orbital, hydrogen, both side. Then s and sp, s orbital of hydrogen and sp orbital of carbon. Then this is also sigma bond. Sigma bond means total 3 sigma bond. Each carbon 1 sigma bond, and between the carbon 1 sigma bond. Total 3 sigma bond. Now what is important here? Now 2 p orbitals has not taken part in hybridization. Then they are present on the carbon, and both orbitals, all 3 you can tell, are perpendicular to each other. Perpendicular to each other, all 3. This 2p also and sp also, what hybridized, all are perpendicular. But only difference that 2p orbitals are perpendicular to each other and not taken part in hybridization. Then same things are with other carbon. Other carbon. 2p orbitals are there and all are, you can say, perpendicular to each other. But these 2p orbitals, here you have to remember that these 2p orbitals of the first carbon and second carbon are parallel actually. Parallel. First p orbital, first carbon p orbital, and first second carbon p orbital, both are parallel. Hence, both will overlap. Okay. In making double bond also, both were parallel. Here, that's why here, just like ethylene, 1,1p, they will overlap and they will make, because both are parallel. Here, second p orbitals of first carbon and second p orbital of the second carbon, again both are parallel. Hence, again both will overlap, side-wise overlapping or lateral overlapping, and they will make bond. Both are pi bond. Hence, 2 pi bond they will make. Hence, including sigma bond, there are 3 pi bond. Okay. Already I have sent the structure. I think previous classes I have sent the structure. Now again I will try to send it. Now here little more things you know here. Orbitals of the other carbon atoms which undergo lateral or sidewise overlapping to form 2 pi bonds between two carbon atoms. Okay. And you can say thus ethine molecule consists of one carbon-carbon sigma bond, carbon-carbon sigma bond 1, and 2 CH sigma bond and 2 carbon-carbon pi bond. Okay, already I have told you that between the carbon-carbon 1 sigma bond and 2 pi bond, 2 CH sigma bonds and 2 CC pi bonds. Already I have told you that in this acetylene CH bond, that is a sigma bond, then 2 sigma bond plus 1 in the carbon-carbon, 3 sigma bond, and 2 pi bond between the two carbon. Now actually I want to tell about the strength. The strength of carbon-carbon triple bond. The strength of carbon-carbon triple bond enthalpy is very high, 823 kilojoule per mole. This is more than those of double bond, carbon-carbon double bond. That is the bond enthalpy is 681. 681 in case of ethene. Ethene it was 681, but in triple bond, now here 823 high, and carbon-carbon single bond further less, that is the 348 kilojoule per mole. Then sigma bond is a weak bond. Sigma bond is weak bond. Then this CC bond I am talking about, single bond alkane, that has a bond energy is very less, 348, double bond 681, and triple bond 823 kilojoule per mole. Means triple bond is stronger than second is stronger than first. Okay, triple bond is stronger than double bond is stronger than single bond. Means alkyne is has a triple bond is stronger than ethine, and ethine is stronger than, you can say, in this alkane double carbon-carbon single bond. And other things, bond length, then carbon-carbon triple bond length is shorter, because whenever this will be there, bond will be strong, then bond length will be less, because they will be closer. They are stronger means they are closer. Then carbon-carbon triple bond length is shorter, 120 picometer, than those of carbon-carbon double bond, 133. And carbon-carbon single bond, how much? That is the longer, 154. Means triple bond length is least, 120, and double bond 133, and single bond 154. Then as the bond length will increase, bond will be weak. But these things, triple bond will be more reactive than double bond, because 2 pi bonds are there in triple bond. That's why they can break very easily. Electron availability is more than double bond. Means ethine is more reactive than ethene, and ethene is more reactive than what? Alkane, because single bond is there. Reactivity will increase according to the number of bond. Electron cloud between the two carbon atom is cylindrically symmetrical about the internuclear axis. Thus, ethine is linear molecules. Ethine, Y-E-N-E, triple bond is that is cylindrical and symmetrical, and this due to this cylindrical and symmetrical about the intermolecular axis, the ethine is a linear molecule. Ethine is a linear molecule, a straight line. Then this I have discussed about the, you can say, alkyne. Alkyne, thus a general way I have discussed nomenclature, isomerism and structure. Now properties I will discuss in the next class. Thank you.